Now we state Lebesgue's criterion for Riemann integrability. Let f be a bounded function defined on a closed interval from a to b. F is Riemann integrable if and only if the set of points where f is not continuous has measure 0. Since f is bounded, let the absolute value of f of x be less than or equal to big M. We first prove the reverse direction. Assume D has measure 0. Given epsilon greater than 0, set alpha equals epsilon over 2 bracket b minus a. Because d alpha is a subset of D, d alpha also has measure 0. Thus, there exists a countable collection of open intervals O sub n, such that d alpha is contained in their union, and their lengths sum to less than epsilon over 4 big M. Because d alpha is a compact set, there is a finite subcollection of open intervals that covers d alpha. Then we can change the endpoints of the open intervals so that they become a finite disjoint collection g sub 1, g sub 2 up to g sub big N. Let K be the closed interval from a to b minus the union from n equals 1 to big N of g sub n. Because f is alpha continuous at every point in K, f is uniformly alpha continuous on K. This means that there exists delta greater than 0, such that the absolute value of x minus y is less than delta in K implies the absolute value of f of x minus f of y is less than alpha. Now construct p sub epsilon by taking the endpoints of the g sub n, a and b, and partitioning K into subintervals of length less than delta. The upper sum of f with respect to p sub epsilon minus the lower sum of f with respect to p sub epsilon is the sum of bracket big M sub k minus mod sub k times delta x sub k, where big M sub k is the supremum of f of x over the kth subinterval, and small m sub k is the infimum. We break this into two sums, one over the subintervals that contain points in d alpha, and one over those that do not. For the first sum, big M sub k minus small m sub k is less than or equal to 2 big M, and the sum of delta x sub k is less than or equal to epsilon over 4 big M. For the second sum, big M sub k minus small m sub k is less than or equal to alpha, and the sum of delta x sub k is less than or equal to b minus a. Thus, the entire sum is less than or equal to 2 big M times epsilon over 4 big M plus epsilon over 2 bracket b minus a times bracket b minus a, which is equal to epsilon, completing the proof in this direction.